Dear students, welcome to Statistics and Dynamics, and thank you for tuning into this video. I'm Dr. Loay Al-Zube, and we are continuing our discussion of Lecture 5, in which that we are going to learn about the position vectors and how can we use them in identifying the force vectors in the Cartesian coordinate system. So we talked about this application. Let's define what a unit vector is actually and how it is being used. The position vector is defined as a fixed vector that locates a point in a space relative to another point. Usually when we say we would like to talk about the coordinates of a point in a space, we always refer them and reference them to the 0, 0 point, the origin point. But if you talk about a position vector, we have two different points, let's say point A here and point B, and we would like to identify this vector R. We don't want to go back to the origin 0, 0 point. What we want to do is to find this position vector that is locating a point in space relative to another point. Consider the point A with its Cartesian coordinates to the origin, xa, ya, and za, and consider the point B with coordinates with reference to the origin as xb, yb, and zb. Now, how can I find R? See this one here. And remember that anything that is R is a position vector, that's not a force. We're going to use it with forces, but not now. I would like to find what R is. So the rule of thumb is that you take the coordinates of B and you subtract them from the coordinates of A, and this way you have this position vector. How to represent the position vector in Cartesian coordinates? So this is the general idea. How can I find the coordinates of R? To do this, as I mentioned before, this is your A, this is your B. A has X, A, YA, ZA, and B also have XB, YB, and ZB. All what you need to identify are the position vector. Remember, this is position, it's not force. In order to find R, you just subtract the X's, XB minus XA, the head minus the tail, all the time, YB minus YA, that's your J component, and the ZB minus ZA, that's your K component. If you subtract these coordinates from each other, then you will end up with a position vector called RAB. And note that A is the starting point and B is the ending, the head. So A is the tail and B is the head. So the notation RAB is always, whatever you start with is the tail and whatever you end with is the head or the arrow where it's directed. And that's your position vector. So please note that all ending point and A is the starting point. Always subtract the tail from the tip. That's our notation in the geometry. We have an agreement now that this is called a position vector. It's a vector because remember you have I, J, K. And now how to represent a force. So let's say I have a force which is 20 kilonewtons and it's directed along that position vector, along R. So how can we represent the new force? Do I multiply the force with whatever we have here? No. So there is another step that we need to do. That's the mistake that a lot of students will make, is that if I told you I have a force that is 10 newtons and it's acting along R, they will multiply the 10 by the R, the 10 by the whatever vector they have. That's wrong. There is another step we need to do, which is identifying the unit vector of R. So the unit vector of the position vector. So how can we do this? For a force vector directed along a line, we represent the force vector in Cartesian coordinate by using the magnitude of the force, the one that we have, F, it's a scalar, and we multiply it by the unit vector of the position vector. So step one, you need to find the position vector. See this one here. I told you, we identify 2 points, A and B, and you subtract B minus A, so XB minus XA, that's I, YB minus YA, that's a J, and ZB minus ZA, that's the K, and those are the coordinates. Once you have your position vector, RAB, you need to find the unit vector of this position vector. And if you remember from previous lecture, the unit vector, we find the magnitude of this vector, the position vector, it's RAB, and you divide the vector itself with by its magnitude, something similar like here, and then you have the UAB. After you have the unit vector, then you multiply the magnitude of the force with the unit vector, and this is how you actually correctly represent force, the force that is acting along a line or a position vector. I hope that clarified the picture. We're going to do multiple exercises and examples in the class so that you know exactly how to use these. Keep in mind, we have something called position vector, and we have something called unit vector, and we have something called the force acting along a line. We're going to combine these three together and to use them in exercises in the in-person session. Thank you for watching, and till the next video. Bye.